Here we have another problem with permutations and combinations. This one says, suppose we want to choose 5 letters without replacement from 13 distinct letters. So what this means is the total number of items is 13. That's our N. The number that we're choosing is 5. That's R. And then we just have to distinguish which one's the permutation and which one's the combination. And to do that, we remember that in permutation, the order matters, and in combination, the order doesn't matter. So this first one here, A, that's our combination. It says, how many ways can this be done if the order does not matter? So we'll just use our combination formula here. N is 13, so this would be 13 factorial on the top of the fraction. And on the bottom, we would have n minus r factorial, so 13 minus 5, that's 8 factorial. And then times r factorial, so times 5 factorial. And then we'd have some computing to do. I'm going to just use a little bit of shorthand. I know that the 13 factorial is 13 times 12 times 11 times 10 times 9. And then the part that I'd write next here would be times 8 times 7 times 6 times 5 times 4 times 1. That's exactly what this is. So that chunk is going to cancel. So I'm just imagining it's there and I'm canceling it. So what's on the top of the fraction is just this chunk because I've canceled out that 8 factorial from it. And on the bottom we have 5 factorial. Oops. So 5 times 4 times 3 times 2 times 1. And now we have some calculation to do. So I'm going to pull up my calculator. 13 times 12 times 11 times 10 times 9. I'm getting a big number, 154,440. Then I'm going to divide by what's on the bottom. Divided by 5, divided by 4, divided by 3, divided by 2. Won't bother dividing by 1. And I came up with 1,287 combinations of 5 letters from 13. Wow, that's a lot. Let's try the permutation next, which should be even more. So the permutation is when the order of the choices matters. It would be 13 factorial on top, because that's our total, and then n minus r factorial on the bottom, so that's just 8 factorial. So that is going to be this chunk right here after we've done the canceling, and with nothing on the bottom, or just 1 on the bottom. So it's going to be that number I came up with first, that 100 and something thousand. So let me multiply that out again. 13 times 12 times 11 times 10 times 9. Yeah, so that is 154,440 permutations of 5 letters chosen from 13 where the order matters. So you can see with these permutations, the numbers can get big pretty fast. So that's a little bit of work with permutations and combinations.